Okay, awesome. Okay, welcome everybody to the Murray Amateur Radio Club. I'm Jan, KD7ZWV. I'm going to be talking about the AREDN Deep Dive series that we're doing this first part of the year. So in Mark, we have 3 classes a month, and our first class is dedicated to basic topics. And we're calling that, this year, we're calling that our Back to Basics series. So that's for people who have their license but have never been on the radio, or people who are just getting their license, or people who've had their license for a while and just want a refresher on some of the basic stuff,
Or allowed their license to lapse.
or allowed their license to lapse and need to get a new one. And so that's our basic series. We have been doing that since the first Thursday of the year. And then our second class every month is our advanced topics class, and we've been doing deep dives on various subjects. Last year we hit WinLink, APRS, a couple other things I can't remember what exactly, but this year we're starting out with AREDN, and this I think is the second session for AREDN. So last month we talked about what AREDN is and how it works and why we are interested in it. This time, we're going to be talking about flashing the AREDN firmware, how to get the AREDN firmware on your devices. And then next month, we'll talk about some of the more advanced features of AREDN and how to configure them and make them work. And then we've got other things coming up in the next few months. So without our third class every month is just some kind of general topic of interest to everybody. So if you guys want to teach a class on a particular topic, I know Jeff really wants to teach one on DMR. We may have him do that, or I may teach it. I don't know. We'll see. But Justin, I want you to teach on electronics for the beginner series.
Yeah, I remember, yeah.
So be thinking about that. I'm not sure where exactly to plug that in, but I think you would be great for that. All right. So let's jump right in here. So AREDN, first, AREDN is the Amateur Radio Emergency Data Network. And what it is it's a way to use wireless ISP hardware to build a high-speed network, an IP network, on Wi-Fi on ham radio frequencies. Okay. So in order to do that, we need to know what the heck firmware is. I talked, we're going to flash our firmware. What is in the world does firmware? What does that mean? So firmware is the actual operating system and software that runs on a hardware device. Okay. So if you've got a microwave, it has some kind of firmware in it that controls it. When you punch the buttons on the panel, you're telling the firmware to do something, and then it does that, right? It runs a clock, counts down, turns the microwave on and off, whatever it needs to do. On these devices, the firmware is a little more complicated than that. It's actually got a little operating system, and it's got some other software that runs with that, but it all runs directly on this hardware. So it's not running on a separate computer. It's running actually on the radio hardware. The stock firmware is the software provided by the device manufacturer. So whenever you buy a device, the manufacturer of that device has put some firmware on that device. And that firmware has certain capabilities that do whatever the manufacturer wanted it to do. Okay. What the AREDN firmware does is it's custom firmware that runs on several different wireless routers, and it includes support for mesh networking. And if you're not familiar with mesh networking, watch the presentation from last month. I go into all the different network types and what mesh networking is and why we care about it. But the basic idea is a mesh network is a self-healing network that automatically figures out what path to take to get from one place to another within the network. Okay. So it's not like a fixed network. New nodes can appear, nodes can disappear. It doesn't break the network. Okay. The firmware also supports running certain applications directly on the routers, and it replaces that stock firmware that the manufacturer has provided. So we're going to overwrite that manufacturer firmware and get rid of it completely and put our own software on there. All right. Yes.
When you overwrite that firmware, does it still keep the capabilities and we're just adding to it? or is it wiping it out?
We're wiping it out.
So your radio may lose some functionality.
Depending on what functionality the original manufacturer had in there, you may lose some of that, right? The thing is, we don't care about that functionality. We care about the mesh network functionality that their software didn't have. Okay. So one example would be maybe your access point hardware from the manufacturer could do multiple Wi-Fi networks, right? So you could have my home network, my guest network, and my work network as separate Wi-Fi networks, all running off the same device. The AREDN software won't let you do that. It could be made to do that, but it's not going to do that out of the box. There's not a way to make it do it out of the box. So that's just an example of one of the things that the manufacturer hard software might provide that the AREDN does not. Okay. So AREDN maintains a list of supported hardware, and you can find it at this link. When I publish this, I will put all the links on the page, so you don't have to copy this page down or try to write this down really fast. That goes for other links that are in the presentation. Only buy hardware that's on the list if you want to work on an AREDN network, because we have experienced where somebody bought a particular device thinking that it would work, and it didn't work. That may be because the radio is not supported by the AREDN firmware. It may be because the manufacturer isn't supported. It may be because the particular hardware uses a different chipset that is not supported by the AREDN stuff. It could be different things. Okay. The AREDN firmware only supports hardware from 4 different manufacturers. Microtik, that's a company based in Riga, Latvia, and they manufacture wireless and wired gear, routers, switches, other kinds of stuff. Ubiquiti is a US company. They also make access points, switches, routers, cameras, door locks, all kinds of crazy stuff they make. You're not going to run AREDN on a door lock, so don't try that. TP-Link is a Chinese company. They manufacture a variety of hardware, including cable modems, phones, routers, switches. They've actually been frowned upon by the government. So it may be hard to get TP-Link hardware right now. It may not be hard to get, but it may be hard to get. There was some concern that the stock firmware might have things in it that allow the Chinese to do stuff that you don't want them to do. Even if they did, we're replacing their firmware with our own stuff, so it wouldn't matter. But yeah, it may be hard to get TP-Link hardware right now. And then GL-iNet is another Chinese company. They manufacture a variety of gear as well. And among them are the pieces and parts that we want to use. Okay. So remember, only specific products from these vendors are supported. So Ubiquiti sells a device they call a Rocket M, and that's different from a Rocket M5 or a Rocket M2. And there's like the Rocket M XW and the Rocket M AC, and those are different. So you got to make sure that the thing that you want to buy matches what's in the supported hardware list. Okay. Very important. Some hardware was supported before, but doesn't work anymore. It doesn't have enough RAM on it. If you ever had one of those Linksys access points, Linksys Wi-Fi access points, the WRT54, the L model of that used to support this stuff, but it doesn't anymore because there's not enough RAM on that system to load this software. Okay. So you need to double check that and make sure that the item that you're wanting to use is in there and says it's supported. Okay. Always check that list. And the firmware only supports a few hardware implementations. It supports ATH 79, the Atheros chipset. That's the most common one. It also, by derivation, supports the ATH 71XX in some cases, depending on if that hardware has enough RAM. The 79 is like a next generation of the 7100 series, and some of them do still work, some of them do not. So that's something to be aware of.
I watch out for the 71 because that's what this is.
Yeah, and that does not work, right? Yeah, so
I would buy anything new.
so you gotta be careful, right? And then there's the IPQ 4000 series, also Qualcomm. It's a newer chipset that's starting to become more popular. I haven't seen it in a lot of things, but I've seen it in a few things. Uh, there's the RAM R8 MIPS, which is a Raylink, I guess. Rawlink. I think Raylink is how you say that. And it's based on the MIPS processor. I've only seen one manufacturer with that hardware, and I think it's TP-Link. So probably don't have to worry about that one. And then they do support building for the PC platform, the x86-64. They only do that because you might want to run the AREDN software in a VM without any radio hardware attached to it. Okay. So it does have the facility to run an instance on a VM using this particular build. You're probably not going to want to mess with that. Most people aren't gonna mess around trying to get that to work. I've tried to get it to work and failed a number of times. So be advised, it doesn't work very well in VirtualBox. It may work fine in some other virtualization system, but like VMware or something like that. But I don't have access to that at home that I want to play with. So, all right, the hardware fits into a few different categories as well. So some devices, you'll find a device that has one radio and an Ethernet port, and that's all it's got. Okay. This right here, this is a MikroTik SXT-SQ.
Is it a light five?
This is what is this one?
SXT SQ light five.
Nope, this is a 5MD, I think.
A five what?
5MD.
That's supported.
Well, we'll find out, won't we?
It's not on the list here.
I don't know. We'll have to see. It may be the same. I don't know.
Oh, you
Anyway.
said HP?
I said 5ND,
Nancy Victor?
Nancy Delta.
Nancy Delta.
I don't want to talk to you. So you can see this device has a radio that's in here. This is the antenna, and then it's got a single Ethernet port on it right there. That's all it's got. There's no power port, there's no serial port, there's a grounding clip for a ground cable, and that's all that's on here. We'll talk more about that in a minute. You might find a device that has two radios and an Ethernet port. The best example of that has been the Ubiquiti Power Beam or Light Beam. Those have the ones that we found have a 5 gigahertz antenna radio for the directional part, and then they have a local 2 gigahertz, 2.4 gigahertz Wi-Fi antenna internal that you can use with the Ubiquiti software as a management network, but with the AREDN software, you can use it as a LAN connection. So people can connect to that with some kind of device, and you only need the one thing. You don't need to have like that plus an access point. You've got everything in one package. You might have a device that has 2 radios and an integrated Ethernet switch. Somebody got an HAP kicking around. There's one right there. They've got 5 ports, 5 Ethernet ports on it, and 2 radios inside. So you can actually select which one you want. It doesn't have a dish though, so it's local area only. It's not going to be something you're going to use for a long shot. But those are great little gadgets for your home test machine or your hub at home where you tie your other devices into it. Yes.
So like 5 gig and 2 gig or something? How could it have 2 radios?
Yeah. 5 gig and 5 point, what is it? 5.8 and 2.4. Yeah. So, or you could have a device that has no radios and 1 or more Ethernet ports. And that would be like my virtual machine installation. Doesn't have any radios on it, but you can still run the AREDN software on it. Most of the hardware uses power over Ethernet and requires 24 volts of power. Now, when I say requires 24 volts of power, I mean the manufacturer said, give us 24 volts of power, but some of them will run on as low as 10 volts and as high as 28 volts. I know people have run these things, these SXTs, off of a 12-volt battery with no problem at all. So take that 24 volts with a grain of salt. Now, one reason why they might say 24 volts is because when you're doing power over Ethernet, if you've got a 100-meter Ethernet cable and you put 24 volts in it at this end, you're probably not getting 24 volts out at this end, right? So that's probably why there's that variation. You got a question?
Yeah, is this your Mestastic type,
No, this is not Meshtastic.
Okay.
Meshtastic's a completely different thing.
this is just the internet access?
It's internet. It's basically a network, an IP network, just like a Wi-Fi network, a Wi-Fi based network. We'll probably talk about Meshtastic later in the year, but right now we're talking about this AREDN stuff, which
What's
is
the average cost?
this I think was
50.
$60, $50, something like that.
I got mine for 50.
You got yours for 50. We bought some used Ubiquity machines from a guy down in Ephraim for $20 each.
Is
Um,
found Streetwave?
Who's Streetwave?
Distribution out in Salt Lake, west side of Salt Lake. They're a national distributor for Ubiquity,
Ubiquity.
and Microtech. They're a few bucks cheaper than Amazon.
Huh. And they're local.
Yeah, they're local.
Streak Wave. Okay.
Streetwave.
I'll make a note of that. Streak Wave.
Street wave, one word?
Yep.
So apparently Streak Wave is a local company that is a distributor for Microtech and Ubiquity. So they might have some deals. We'll see how that turns out. Have to check into that. Okay, so the one thing to note, the PoE on these things, PoE is a standard, and there's like switches that support that, and there's a way for the switch to talk to the device and find out how much power it needs and set things appropriately. These devices don't do that. They expect 24 volts passive. So they're not going to ask for power, and they're not going to know what to do if you give them too much power. If you give them 48 volts, I don't know, it might catch on fire or something. I don't know, probably not, but it just won't boot. Yeah, okay. So the key factor is
Everybody, Chief Joey is not in the room, just so you know.
Turn open mic, erase that recording.
The key thing to remember is they want 24 volts and it needs to be passive PoE. So these devices typically will come with something like this, which I can show you in my hand, but I can't really show you on the Zoom very well. Basically what it's got is a network port on one end, a port for a cable on the other end, and a power injector port here. You plug your power supply in here, you plug this into whatever your network is coming from. The cable from here goes to your device and takes the power to your device. So this injects the power into the Ethernet cable.
And what's that called?
Injector. It came with that. Power injector. Generally, it'll be included with the equipment when you buy the equipment. So when we bought the Ubiquity gear, they all came with a suitable power injector with them. Okay. Let's see. All right. So how do we get the firmware on the device? Different manufacturers' hardware requires different ways of installing the firmware. There's a website right here. It's on the AREDN AREDN documentation site, and it describes exactly what you need to do to install the firmware. So if you read through that, it'll walk you through it for each of the different hardware vendors. Ubiquity, the way it works is the node itself, which would be the device, runs a TFTP server, and TFTP is the Trivial File Transfer Protocol. And it's a really simple protocol. It was easy to build into chips back in the 70s. So it's really, really easy to build into chips nowadays. You use a TFTP client on your computer to send the firmware file to the device, and then it loads it. Or if you have a shell access to the device, you can SCP the file up or use a secure copy program to copy the file up into the device and then install it from the shell. Okay. MikroTik and TP-Link, you do it a different way. basically you run some software on your computer called a Pixie boot server, and I can't remember what PXE stands for. It's yeah, that's it. Pre-boot execution environment. Yeah, I think that is it. And so what happens is the device comes up and it says on the network, "Hey, I'm here. Somebody tell me what to do." And the Pixie server will say, "Oh, you're going to be this IP address, and here's a file to boot." And it will copy the file over to the device, and then the device boots it, and away you go. GLINet, their stock firmware lets you just install whatever you want. It doesn't care. So the other ones, if you tried to install the AREDN firmware with their stock tool set, their stock interface, it'll say that's not a Ubiquiti firmware, or that's not a MikroTik firmware, and it just won't do it. But the GLINet, it doesn't care. You can give it whatever, and it'll say, "Oh, thanks, I'll boot that. Why not?"
For what it's worth, these you can load right from the stock owner.
The which ones? The TP links? Oh, you can?
All of them. These TP
Those ones
links,
can?
standard ones, yeah, super easy.
Okay.
But,
Well, that's cool. That's good to know. All right. Let's see. Oh, here's an interesting point. You may need to upgrade or downgrade the existing firmware on the device. We had to do this with the Ubiquitis because the AREDN booting process only works if you have a specific version of the Ubiquiti software on the device already. So you need to either upgrade or downgrade the device to the correct version of the Ubiquiti software, and then you can do the booting process, the TFTP process, or the SCP process, and get it to work. You'll need to have the appropriate client software on your machine, or the Pixie boot server on your machine, depending on the machine the device that you're trying to set up. You'll need to install that most likely if you're using Windows, but Linux and Mac OS typically already have it pre-installed. They depends on your distribution and depends on the version of the operating system. Some don't, some do. Most of the time, it's already got what you need. Windows, you'll have to install it. You'll need to be able to manually set the IP address of the Ethernet port on your computer. You will need a wired Ethernet port on your computer to make this work, most likely. And later in the installation, you'll need to be able to reset your Ethernet port to DHCP mode, because at some point in the process, the device will provide you with an IP address, and you'll need that to be able to connect to it and configure. We'll talk about that as we go through. And the procedure for doing all of this depends on the operating system, what kind of computer you have, and all that. So if you run into problems, we could figure it out. We've done a lot of these, so we can definitely figure out how to make your stuff work. Okay. All right. You need to download the correct firmware image for your device. This is the website you go to find the right firmware download file for your device. On this site, there's a little input box. You type in the name of the device you have, and it will say, "Oh, here you go. Click here," and you click there, and it has the files you need to download. You'll also need to know what version of the AREDN firmware you want to install. In general, unless you have a reason not to, you want to install the latest released version. They also have previous releases back, I don't know how many they have, like to 3.14 or something like that. And they also have nightly versions. Now, I said on here, the latest release version was 3.24.10. That is no longer correct. As of last week, the latest release version is 3.25.2. And if you look at that, 3 is like the overall version number that defines the compatibility between the different AREDN releases. The 24 or the 25 is the year, and the 2 or the 10 is the month that it came out. And then the .0 could be a .1 if there was a bug or something and they had to release a new version right away to patch that. So when you look at that on the install page, you'll see now 3.25.2.0 is the one that comes up as the default. They also do have nightly builds available, and if you want to live on the bleeding edge, you can install the nightly build. What they do is every time somebody checks in new code, it does a build and produces a new version of this stuff. And if you're interested in the latest and greatest and you don't care about bugs, go ahead and run that. I wouldn't run it on something that's mission critical or that you really are depending on. But if you've got a test bed machine, why not? You might want to see what some of the new stuff can do. So it can be kind of fun to play around with that. There have also been cases where someone I was talking to had a particular piece of hardware that the release version wouldn't work on, but when they installed the newest nightly at that point, it did work. So I don't, was that, I think it was Jed. Jeff, do you remember who that was?
No.
I don't.
Fiddler, is that what we did? Sam Fiddler? By chance?
It might have been Sam. Yeah, I think it was Sam.
Yeah, that's what we did.
I think it was Sam. Yeah, yeah. So, but now that 325.2 is out, all of those fixes should be rolled in there. So 325.2 should work. On the deployed node, when you have it running on the node will automatically, if it can reach the internet, it'll automatically detect that a new version is available and offer to install it for you. If you're running the nightly builds, it'll detect a new nightly build is there and offer to upgrade that. You may not want to upgrade to every nightly build. You may want to check the release notes first. Just keep that in mind. Sometimes the nightly builds are more experimental than you think. So, okay, so how do we get the firmware on our device? We follow the instructions for our device manufacturer. We install the firmware, and it's going to leave your node running a pre-install interface. Okay. It'll restart automatically. You'll need to make sure your network connection on your computer is set for DHCP, and then you'll connect to the device using a web browser, and you'll see the first boot interface. And on here, you're going to set the new password and node name. The node name you type in here has to start with your call sign, and it has to be in uppercase. Okay. So I don't know if that's required by the software or if it's a convention, but that is what they say is that it's required to start in uppercase call sign. So this is what that first boot screen is going to look like. And you put in the node name, you make up a password and put it in. I'm going to talk about both of those things in a second. And then you hit the save and reboot. And when it comes up, it'll be ready to roll. So the node name is the name that the device will have on the mesh. Okay. Needs to start with your call sign, has to be in uppercase. It can be a total of 63 characters long. It can have letters, numbers, and dashes in it, but it can't start or end with a dash. Obviously, it can't start with a dash because your call sign doesn't start with a dash, and it can't end with a dash by itself. It has to have a letter or a digit after the last dash. The recommendation is to keep that node name as short as possible, and it has to be unique on the entire mesh. Now, since you're using your call sign to name these things, you get to decide what the rest of the name is, and you just have to be consistent. Yeah, Jeff.
Just as a side point, it's the node name that kind of satisfies the FCC requirement to ID your
Correct.
transmission.
Yes. So every time this device beacons or sends out a packet, its node name will be included in that, and that will satisfy the FCC ID requirement. Remember, the FCC says you've got ID at least every 10 minutes or at the end of your communications, right? And at the end of your communications. So having that in there makes it basically identify on every transmission. Okay. Some examples I'm using no call here, N0CALL. Obviously, that's not a real call sign, but you would substitute your real call sign. And I have no call -1. That might be my first device. Then you might have another no call -2 and a no call -3 or whatever. That's great if you remember which one is where and what they're doing, right? Some people like to put in the model of the device. So no call SXT3 would be my third SXT device. Some people like to say where it is and what direction the antenna is pointing. So no call IMC 160 would be a node on top of Intermountain Medical Center that's pointed at 160 degrees down the way. Yes.
Oh, I was crossing my fingers.
Oh.
Let that happen.
Paul's working on it.
I know.
Paul's working on it. So we'll see. We'll see what happens. You might have a mobile device. No call mobile 2 might be your second mobile device. No call GK1B might be the, so you've got a Go kit. So it's your first Go kit. So that's GK1. And then B means it's the second device that's in that Go kit. Maybe you've got two devices in there, A and B. So you can name it whatever you want. Pick something that makes sense to you and use that. So the nodes that I have at home are KD7ZWV-0 and -1. -0 is my HAP and -1 is my LDF5. So I know which one is which, and I'm not going to mix them up, so that works fine for me. Okay. So password. The password is used to control access to the admin interface. So when you bring that node up and you see the first interface, it's like a node status page. And anybody can see that, okay? But if you want to make changes to the configuration of the node, you have to go into admin mode. And so in order to do that, you've got to give it the admin password. It's also used for shell access into the node if you SSH or telnet into the device. You'll need to know it when you want to do anything with your device. So pick a name or password that you can remember, okay? It doesn't have to be complicated. There's no rules that say it must have 14 characters with 3 uppercase and 2 lowercase and a digit and a punctuation character. There's no rules like that. You can make whatever you want. It just needs to be something you can remember. Now, if your node is going to be in a larger network, in an infrastructure role or in a group or something like that, you might want to all use the same password within that group. Why would you want to do that? Well, because then any of the operators in that group can manage your node and you can manage their node. So if the node starts screwing up and doing something crazy, you can connect into it and turn it off. And the owner doesn't have to be the one who does that, right? So if it's your own personal stuff, then pick a password that only you know, and that's fine. Well, the passwords can contain upper and lowercase letters, digits, and special characters, dot, dash, underscore, exclamation point, and that last one is a tilde if you can't see it on the screen very well. They recommend staying away from any characters that might be special in any way to Linux systems. So things like $, less than, greater than, you probably want to stay away from those. It's probably not going to break anything, but why take a chance? Just stick to the punctuation characters that are shown. You will need to enter the same password again in the second password field. So they give you 2 password fields right there. Put the new password in and then retype the password. If they don't match, it won't let you go on. Okay. And then you click save and reboot when you're ready. On the second boot and later boots, that basic configuration will already be done. The node will reboot as a fully functional mesh node, and it'll pick an IP address for the mesh based on its MAC address. It'll configure DTD and LAN ports on net 10 addresses, and it will configure the WAN port to use DHCP to acquire an address. Okay. Where did all these ports come from? My SXT only has 1 Ethernet jack on it. Where's all these ports, right? Some of the devices, they only have 1 Ethernet jack, but with VLANs or virtual local area networks, you can have multiple networks attached to a single Ethernet port. Now, the way this works is there's a feature of Ethernet called VLAN tagging. And what it does is it adds an extra piece on the end of the Ethernet header that says what VLAN this packet is part of. Now, you may have packets that don't include that, and those are considered to be untagged. And packets that do have that are considered to be tagged, and they will have a specific VLAN number. On these devices that have a single interface, any untagged traffic will go to the LAN network connection on the operating system, on the system. If you're on VLAN 1, it will be considered to be a WAN port, a wide area network port. And if you're on VLAN 2, it'll be a device-to-device link. So what this actually means. Let's talk about what the difference is here. So LAN ports are local area network ports. So if you've got devices that you want to be on the mesh, like maybe a computer or your laptop or your phone or your tablet or whatever, if you point them at this device, they're going to want to be on the LAN. So the device will give them an IP address with DHCP, just like your regular router would at home. And you can be on the network and you'll be on the mesh like a fully functioning mesh machine. You'll be able to access anything out on the mesh. Okay. The WAN port is the wide area network port, and that's if you want your device connected to the internet. Okay. The internet would be the WAN. It could be your home network. Okay. Could be the WAN port. And so on that port, the device is going to be acting as a DHCP client, and it's going to be trying to get an IP address from your router, for example. Okay. And then the DTD interface looks just like a LAN port as far as you're concerned, but it's specifically for two devices to talk to each other directly. Okay. So if I have an SXT and Dan has an SXT and we're both in the same room, we can talk to each other over the wireless connection. But since we're both right here in the same room, we might as well just run a physical wire between the two and get better performance, speed, security, whatever over that link. That's going to be a DTD link or device to device link. Okay. The node interface will show you different things depending on if it's a DTD connection or a LAN client or whatever. All right. Devices that have multiple ports, like the HAP, the first port on that device is going to be the WAN port. So any untagged traffic on that port will be considered to be WAN traffic. The rest of the ports are either LAN ports if they're untagged or DTD ports if they're tagged for VLAN 2. Okay. The device will always use VLAN 2 for the DTD interface. Yes.
Do the DTD ports just work automatically?
It's completely automatic. You don't have to mess around with anything. It just suddenly shows up as a DTD connection because they're both using the VLAN 2 tagging for that network. So they always know that that's a DTD connection because it's got that tag on it. The fifth port on those devices will also provide 24 volts of PoE. So at my house, I've got my HAP. I've got the WAN port connected to my home network. I've got the port 5 connected to my LDF5, and that shows up as a DTD connection. And then the other 3 ports are available if I wanted to plug a Raspberry Pi or something into it. Okay. I don't have any other services on there right now, but that's yet to come. So that's the basics for that. Okay. So next month, we're going to be digging into more advanced configurations using the main interface. Later, we'll do some network design and we'll talk about how to plan out your network and where you want to put your nodes and figure out where your links are and what's going to work effectively. And then later than that, we'll talk about different applications that can run on the mesh and why we're doing this in the first place. Okay. After that, we'll see where we go. But for now, that completes the presentation. And we've got 45 minutes left to do some installs on people's gear. So I'm going to go ahead and stop the recording.